Okay, so you learned a little bit about the atmospheric circulation. We talked about land breeze, sea breeze, and how that can be extended to the monsoon circulation over India. And the monsoon circulation is not just over India. Anywhere where the winds change direction during the year from one season to another, we call it the monsoon. So there is the African monsoon. In fact, there is East African monsoon and West African monsoon. There is Australian monsoon. There is even a North American monsoon. Of course, the most famous monsoon is the Indian monsoon because it's so dramatic, and in fact now on May 21st the whole country is waiting very eagerly for the monsoon to get started. And here the monsoon is the word that comes from Mausam, M-A-U-S-A-M. Some of the Indian kids listening to this may recognize the word. It means season in Hindi, and apparently this came from a Persian word from Arabs who long time ago discovered that the winds change direction completely, so they wanted to come from the Middle East, let's say across the Arabian Sea to India to do some business, sell things, spices, whatever else. So when they wanted to come this way, they realized monsoon season is the best because the winds are going from the Middle East towards India. Right, that's what we saw here. Let me put this into display mode. Let me bring up the pointer. So winds are going this way. So if you're starting on this side, the Middle East, you can sit in your boat and just use the winds to come this way. But going back in the monsoon will be difficult, so you'll have to wait till the winds change, and then you get the northeast monsoon winds, and then you can go back. So they call it Mausam, or the season, and now it became over time monsoon. So now the next concept is to extend this idea to the entire Earth system. I think you all have some idea what a system means, but it's very easy to explain what a system is using the human body. So your own body, you are aware that as I'm moving my hand, I'm using words, I may get thirsty and I may lift a glass of water and drink, or I drink some tea. So there are many things that are working to make this happen. The brain is working, hopefully. My hands are moving because blood circulation is happening, which means the heart is pumping, and when the hand moves, there are bones inside, there are joints, so the skeletal system is working. So you can see here some animations from this giphy.com website, which is showing the skeleton, the runner, the pumping, the muscles, and here it is showing the digestive system, the nervous system, and so on and so forth. So what is a system? A system like this has multiple components. We have a skeleton, we have blood circulation, we have digestion, we have neural system which sends signals from the brain all the way to the tips of your fingers and toes and legs and my eyes and so on and so forth. So each component, like the hand by itself, doesn't do much. If you cut off the hand and put it somewhere, it's not going to do much, right? It's going to die. Or you may have some handicap where you are disabled and your hand is not working for some reason, so the system is not functioning. So each component can do something only when it's part of the big system, and the system can do more than what each component can do. My hand by itself cannot do much, but when it's connected to the brain and the circulation, and when I eat food and I got the energy, I can do weightlifting and so on and so forth. So you can think of a cat that may be blind, but it's alive, it's breathing, so its system is functioning, not completely but quite well. If it can manage to get around, it may be deaf, it may be paralyzed, and so on and so forth. So as long as it is breathing, it is living, so the system is functioning at some level. So that's the idea of a system. There are details of how a system is always in non-equilibrium. Does that mean something to you? Well, if you're old enough to understand, you can follow up. I have lectures on systems in my other courses on the YouTube. There are also lots of documents, animations, and a lot of information on Google if you can find that. So now we will translate this idea to the Earth system. You already got the idea that Earth is a sphere, it is rotating around its axis, and because of the shape of the sphere, we end up with more energy per unit area from the sun in the lower latitudes than higher latitudes. Everything gets warmed up and then energy is going back out as the thermal system. So energy deficit at high latitudes, energy surplus at low latitudes. We said we will need winds to move the energy. We saw how the winds get set up with the trade winds, the westerlies and the easterlies. Of course, when you move energy, just the winds are not enough. It has to move either clouds, because remember, clouds are formed by taking energy from the ocean and putting in the atmosphere, and that energy is released when rainfall happens, and clouds move all the time. So if you pick up water vapor and form clouds in low latitudes and move them to higher latitudes, you will essentially move energy. So you can move energy in this way, water vapor essentially, and you can also move heat. Temperature is warmer in the low latitudes, colder in the high latitudes. So if you move warm air north and bring cold air south and mix them up, then you are moving essentially some energy northward, which is what we do. Then you also have cyclones and hurricanes and thunderstorms and so on, which are moving energy in their own way at different time scales. So you have clouds, water vapor, winds, oceans are being moved. We'll look at ocean currents in the next podcast or after we finish the Earth system. If there are winds blowing, obviously ocean is going to be dragged by the winds, and ocean will evaporate, which means it's going to get colder. And we'll get back to what else happens when you evaporate ocean water. Has to do something with what's in the ocean water. What is in the ocean water? Can you just drink it? Of course not, because think about it. Okay, so we will come back and discuss how Earth itself is a system, and we are not only a system ourselves, but we are also part of the Earth system. What does that mean? That means when we take out coal and burn it, we are putting greenhouse gases into the atmosphere, and we are changing the energy balance, remember, because CO2 is a greenhouse gas, which means we are trapping the energy, thermal energy that is trying to go out to space, which means we are warming the climate. So we ourselves are now part of the system. Often this is called the natural human system. If you think of the natural system with its mountains, its oceans, its vegetation and deserts and rain and clouds and so on, human system is now changing the natural system by deforestation, by burning fossil fuels, by doing agriculture, by building cities, and so on and so forth. Why is building cities important? Usually when we build cities, we have changed the land from what it was, let's say like a rural area, into lots of buildings and roads and so on. How does that change the energy balance? Think about it. Albedo, the reflection of the sunlight, or the scattering of the sunlight, will change because a vegetated area will be very different in its albedo compared to a city with all its cement structures and so on. Right? So anything we do that affects the energy balance is also called a forcing. And now we are a forcing. What are the other forcings? Of course, naturally there is energy surplus and deficit. Plus, we'll also look at volcanoes. Volcanoes are also a forcing, because just like we are taking out fossil fuels from under the ground and burning it. Volcanoes are taking out material from below the surface and throwing it into the atmosphere, the dust, the ash, the chemicals, which also change the albedo and block the sunlight, and they can also change the radiation budget or the energy budget, and hence they are also a forcing. So essentially it's all a system. Within the system you have the geologic system with its mountains and deserts, and you have the ecosystems with their vegetations. Ocean also has an ecosystem, and you have the biosphere. You can ecosystem and biosphere are essentially the same thing. You have the chemical system with all the greenhouse gases, and you have the human system now also acting very powerfully to change the energy balance. So this is the system. So once we have this background on the earth system, we can now, sorry about that, we can now move and look at how the earth system itself works. Okay, so we'll look at few diagrams, and that's the way the models of the earth system are built. When you want to do something about the future, you want to say how climate will change next year, next season, next 10 years and so on, you have to do some model of the earth system, and it becomes very complicated, and you will need a big computer to make simulations of this earth system. So we'll see how these earth system models are built, which means it will have mathematics, it will have physics, it will have chemistry, it will have biology, and of course it will have all these energy balances and so on and so forth. Okay. We'll come back and see that in the next podcast. Okay.